Hello and welcome to this Aftermaths episode of the Primary Maths Podcast, the show where we talk all things primary maths. With me, John Cripwell.
And with me, Becky Brown.
Hello, everybody. Hello, Becky. How is Orlando? It looks very, very similar to Southampton, actually, doesn't it?
Yes, doesn't it? Yes. As the listeners, watchers will probably realise, I haven't gone on holiday yet. We're doing a little bit of bank recording. If only I was in Orlando, but yeah, still at home.
I mean, you will be very soon. You will be very soon. So, yes, this is another of our summer specials. We're taking a step out of the classroom for a few weeks over the summer and just bringing you some things that we feel are quite interesting with a loose, very loose sometimes, link to maths. So, Becky, I'm going to start with a quick game for you, okay?
Yep, okay.
I want you to give me a probability or a simple... a probability, not a simple yes or no, a probability for these events. Okay?
Okay. Yep.
Nothing too challenging here.
Okay.
All right?
Yeah.
The sun will rise tomorrow.
Certain.
Well, I'm glad you're an optimistic sort of person. But it tells us a lot about you, doesn't it? Yeah. The fact that you had to pause before you gave the answer. This could be a long episode, guys. Strap in.
Okay. Certain.
It will rain in Southampton tomorrow.
Unlikely.
Okay. I like that we're going... normally when we talk about probability in maths, we tend to give it a number, don't we?
Oh, yes.
A percentage or a decimal or some sort of description. But we've turned into the primary English podcast here, and we're just using words now to describe things.
Well, the reason is that apart from obviously certain and impossible and an even chance, I'm sitting on the fence a bit with words like...
You are a little, aren't you? Okay. That's fine. That's fine. If I was going to push you, less than 50% chance of rain?
Yes, I would say... I haven't looked at the forecast for here tomorrow because I'm not going to be here, but I think it'll probably say 10%.
You don't care, do you? You don't care whether it rains here tomorrow or not because you're not going to be here. Okay. England will win their next match. Now, when I wrote this, I just wrote England will win their next match. I didn't say in what sport. So pick a sport, Becky.
I'm going to choose football because it's still in my mind.
Okay. So England will win their next competitive match.
50%.
Oh, okay. So we're saying that the team that finished third in the World Cup, the third best team in the world, has only got an evens chance of winning their next match.
This is why I should have gone with likely.
Well, you would have said likely, would you? Because that's not the same as 50%, is it?
I know. I don't know. No, I'm sticking with 50. I'm still disappointed.
You're a pessimist. You've gone from an optimist to a pessimist here. But we've talked about this before. This is why humans are not great at probability. We lost one match, really, at the World Cup. We either drew or won all the others, but it's the one that sticks in your mind is the one that we lost, and therefore now your feelings about England's chances in any match. We could be playing, you don't even know who we're playing next. We could be playing Luxembourg. No offence to Luxembourg. Okay, the next song selected by Spotify will be one that the listener likes.
Oh, okay. Likely, hold on. Okay, likely is the word I'm going to choose.
Okay.
But the percentage I'm going to give is 75%.
Wow. Okay. Based on what?
Because I think Spotify's got this intelligent, and it's not real intelligence, but this artificial intelligence that does use your previous listening, doesn't it?
So the algorithm, yeah.
The algorithm, yeah, to suggest something. And it's probably going to pick something in a genre you'd like, maybe something by an artist you like. So I think it's more likely than not that you're going to like the next song that it picks for you.
Now, I didn't say that it was the listeners' Spotify that was going to choose the song. So that would change things, I guess, for you.
Yeah. Oh, well, yes. That would make it lower. You might have a 50% chance, unless it would depend on you, wouldn't it? Are you a music lover? Are you not a music lover?
So as anybody who, I was talking to my friend Em about this the other day, anybody that knows me knows that my music taste is beyond eclectic. It goes from 50s through to present day, depending on my mood, depending on a whole factor of stuff. So my algorithms on my music platform of choice are all over the place. It is very confused. It's very, very confused. It's not yet intelligent enough to know, okay, John's didn't sleep very well last night. The sun is shining though. He's at work today. He's feeling a bit tired, but he's got to go to the gym. Then it should pick, there's a very particular selection of songs that would suit that particular moment, isn't there? And I don't think it's quite there yet. No, it does pretty good. It does a pretty good job, but it's not there yet.
It also depends on whether you share your Spotify account. Ours would come across as very eclectic, but that's because we've got a 13-year-old, a 15-year-old. One of us is very much into heavy rock and heavy metal, and one of us isn't. So
I'm getting that to you. Yes.
That's not me. It's not more.
No, you're more on the musical side of things, aren't you?
Yes, definitely.
So it's interesting because I actually wrote here, we are more comfortable. This is what the research shows us. We're more comfortable saying almost certainly than we are saying 97%. So it was really interesting that you went for language over a figure. And the sun rising tomorrow, you said certain, didn't you?
I did, but I paused for quite a long time.
You did pause, yeah. I mean, would you say 100%?
Oh no, because there might be some kind of cataclysmic.
Yeah, there could. There's a fractional. We know. Our lived experience suggests for the last couple of billion years, the sun has risen.
Yeah.
But there's an infinitesimally small chance that it might not. In which case, nobody will hear this episode, and that'd be very, very sad. But yes, there is that when we're trying to be precise, there is that feeling that you can't actually say 100%, isn't there? It's just really, really interesting. So what we're talking about today is whether maths can really predict the future. We've talked a little bit about probability recently, and that's what gave rise to this. And in an episode coming up, we're going to be thinking about, can maths help you win games as well, which is also sort of probability based as well. But I find this sort of thing quite interesting to think about a little bit. So can we just define our language a little bit before we start, Becky? Is that all right? So when we think about a prediction, we're thinking about a claim about what it will happen. So that's our prediction. I predict that this is going to happen. That's different to a forecast. How would you say what's your understanding of how that differs?
I don't know.
So if we think about the weather forecast, it's based on an estimate of what is likely to happen, which is slightly different from a prediction. A prediction is a claim about what will happen. It will rain tomorrow. Okay. A forecast might say there's a 70% chance of rain in this particular area. And as we've talked about before, that doesn't mean that there's a 70% chance it will rain, more that there's a chance that in that area, or in 70% of that area that they're talking about, for instance, Derby, some rain might fall, which is very different and quite counterintuitive and a little unusual. But a forecast generally has some uncertainty attached to it.
Okay.
And then a projection is what we are fairly confident will happen should certain assumptions remain unchanged. So we can project into the future, knowing what we know. If these things stay the same, then this will happen. And we use projections all the time. We use them in school when we're looking at things like progress and things. This child has made X amount of progress over time. If they continue in the same vein, then we project that they will achieve X, Y, or Z by the end of the year. And often we look at that on cohort level data as well, don't we? This cohort has done so well previously. Our projection is that if this continues, this might happen. Although maybe that's more of a forecast, I suppose, because we can't be certain, can we? We can say what's likely to happen and what's not. But a projection is sort of an if this, then that kind of statement, really.
Okay.
So, for instance, if birth rates, migration, and mortality follow these assumptions, then this is what the data will be. This is what the population will be approximately in 10 years' time. So, yeah, we talk about projections with data quite a lot. But it's not claiming to know exactly. It's not quite a prediction of the future. Projection and a prediction, different things, I would say. And if you think back to COVID, we had all sorts of projections, didn't we, about the things that might happen when we talk about rates of infection, mortality rates and things. There were lots and lots of projections, many of which did not come to fruition. And sometimes what I found interesting learning about this is that sometimes just making the projection can actually influence the outcome. So when we're given daily updates during COVID about what might be happening with the virus, if you think back to that time, a very strange time it was, you think back to that time, just the giving that data out every day actually changed people's behaviors, which then changed the projections, which is interesting when you think about it, isn't it?
Yeah. I think that all these different things, what if we had predictions, projections, forecasts, are what probably makes it really difficult to know, or we think maybe that maths could help to predict the future, but that's not really what it's doing. It's making projections based on statistics or trajectories or limits and things.
Yeah. So an interesting from history, a story of when mathematical prediction worked particularly well. Edmond Halley, you've heard of the name Halley? So Halley was interested in space and comets in particular. And he was looking back through the records and he saw that particularly bright comets had been spotted in the skies in 1531, in 1607, and in 1682. Now, he used Newton's ideas about gravity and planetary motion, and Halley argued that these were not three different comets, they were the same comet, and it was traveling in a particular manner that meant that it would come past the Earth every 50 years. So in 1705, he predicted that it would return in 1758. Did I say 50 years? It's not quite 50 years, it's 70-something years. I apologize. However, he predicted that it would return in 1758, and it did. It did. And he would have been delighted had he not died, sadly, in 1742, and therefore didn't witness it. However, that comet was named after him then, and it really changed the way that we thought about planetary motion and things, and the bodies in the universe that are not necessarily part of our solar system, that visitors to our solar system. And so that was the first comet that was recognized as periodic, and his prediction that it would return was seen to be true. And we still talk about Halley's Comet today, don't we?
We do. And I should imagine there was an awful lot of maths and probably some physics thrown in that was built, that worked towards that prediction.
What's interesting is that we can predict what comets we might see in 50 years' time, but we can't accurately predict what's going to happen with the weather in 3 days. Which is frustrating, isn't it? But a lot of that is down to what we can predict, because things don't always behave in the way that we think that they might. So a comet, Halley's Comet might change trajectory if it for some reason comes close enough to a large body that slightly alters its direction. It might change, but so far it hasn't, I suppose.
Yeah, it's quite similar, isn't it? I think often we see things about this around space and things. The discovery of Neptune, I think, was particularly was a prediction. They predicted that it was going to be there for whatever reason and where it was going to be, and there it was. But I don't know if you're aware of the search for the planet Vulcan, which was
right. I may have seen the show.
Yes. Well, it didn't exist, but
No, it didn't. No, it was part of a show.
But people were sure it did. It was
Oh,
the
okay.
mid 1800s. I've got to just check my notes that I'm giving you the right years here. Yeah, it's from 1859 to 1915 that
Okay.
people were searching for the planet Vulcan because they were sure that there was a planet, because of all different things that were being looked at, maths and physics wise. The maths was right, but the physics was wrong because there was so much unknown, and I guess there still is a lot of unknown in lots of areas, and it actually never existed at all, and it was mixed up amongst Mercury and things like that.
Okay.
It within limits, I guess. It's like you're saying, we don't know. There could be a gravitational pull issue that means Halley's Comet changes trajectory. There are limits to what we know and what we can apply. I guess sometimes it's not always going to follow the path we think it's going to follow.
Yeah, and certain things can have a larger effect than we might give them credit for. We've all heard of the butterfly effect. Essentially, if a butterfly flaps its wings in a forest, there's a tornado in, the other side of the world. That does not literally translate. That'd be terrifying, wouldn't it? There'd be a mass. Everybody would be trying to hunt down butterflies and stop them from flapping their wings. But essentially, a very small change in one area can have a dramatic impact in another. That's what the theory suggests anyway. I hadn't realised that was quite a recent theory. It was only the 1960s that the butterfly effect was first talked about by, interestingly, a meteorologist, somebody who predicts the weather. And they were trying to improve their forecasting, and they were concerned with these very, very tiny changes and fluctuations in weather patterns that can have enormous effects. And we know, don't we, with things like climate change, that just a small degree rise in temperature, average temperature, actually can reflect enormous changes. And we're currently this summer living through some of the hottest weather I can remember.
Yeah.
And when we look at the average temperatures, probably at the end of the year, they probably won't, in terms of averages, be that much higher than in previous years. But that's where those averages can mask quite an important story, I suppose.
Yeah, I did fall down a little bit of a hole looking into chaos theory, and I can't begin to explain lots of it because it is well above my head. But yeah, I was looking into it as well and thinking it was Edvard Lorenz, I think, who was the
Edvard Lorenz, yes. In the 1960s, he was running a simplified weather simulation on a computer. I'm going to read this little part to you so that I don't get it wrong. But essentially, he wanted to repeat part of a previous simulation. He entered a starting value from the computer's printout. The printout showed a rounded number. We know how important rounding is, something like 0.506. While the computer's internal calculation had used more decimal places. So the printout rounded it, but the computer actually was a much longer number, shall we say, a more precise number. Yeah. Lorenz didn't expect it to have much of a difference on the outcome. We're talking about tens of thousandths or hundreds of thousandths or millionths, when we're thinking about place value here. And at first it didn't have much of an effect at all. But the further into the distance time-wise that the forecast went, it became a bigger and bigger separation until they produced completely different sets of weather forecasts just from these tiny, tiny changes. It wasn't a malfunction or anything like that. It was just that the forecast amplified those changes over time, essentially. And he wrote a paper in 1963, Deterministic Non-Periodic Flow, catchy title. But that helped to establish the modern study of chaos systems and chaotic systems. And that's where the butterfly effect came from, essentially, this tiny change that can happen somewhere that has a massive impact. However, chaos theory, as we've said, is not the same, or chaos is not the same as randomness. No. So it's not that random things happen. It's just that, so a genuinely random event could be radioactive decay. So scientists use radioactive decay when a radioactive isotope emits a electron, I think. Might be wrong there, or a neutron. Might depend on the isotope. Anyway, when it does that, that is genuinely random. So you cannot predict when that is going to happen. That is random. A chaos system follows rules, though, and you can have some prediction provided you know what the values were that were changed or that were different. So it does follow a system. But it's interesting. And this is not primary maths, clearly. And I'm probably way out of my depth with it. But I do think it's interesting to look at, can maths predict the future? It probably depends on your definition of predict, doesn't it? Can it forecast the future? Probably.
Yeah, and I think it all comes down to, yes, but there may always be an unpredictable element somewhere. That's the thing. Nothing is 100% predictable.
The other thing that you have to take into account is, as we said during the pandemic, human influence. So people are on a grand scale, on a population scale, people might be predictable. However, we know from things like polls, political polling and things over the last few years, that even isn't necessarily always the case. And you look back to things like the Brexit referendum and things, the polls suggested one thing, the predictions all suggested one thing, and actually another thing occurred. The same with the elections in America and things. The polls seem to be these days more wrong than they are right. So it is incredibly difficult to predict things that humans influence. And humans influence a huge amount of things these days, including climate, potentially, and things like that. You know, the things that we do as humans, the choices that we make can have huge consequences. You know, the wildfires, for instance, that have been raging even up in Scotland. I couldn't believe that, Becky. You know, Scotland is not the place for wildfires, is it?
You wouldn't think, would you? But again,
no, it should be sort of drizzly and, you know, a little bit wet.
Right.
But wildfires, crazy. But a lot of these wildfires, not all of them, but a lot of these wildfires are started by human actions, which then have enormous consequences. A small action here, enormous consequences for lots of people and wildlife and environments and all those sorts of things. So we do not live in a perfectly predictable world because we ourselves are not perfectly predictable creatures, are we?
No. And it's why lots of science experiments take place in vacuums or, you know, so there's no outside influence. And we know that real life just doesn't work like that.
No. And when it comes to teaching, I would say that's triply true because if you think humans are unpredictable, human children are way more unpredictable. And that's the way we want it to be, though, isn't it? I think so.
Yeah.
Kids should be unpredictable. If you can't be unpredictable when you're a kid, when can you be? Yeah. But that is where some frustration arises sometimes, I think, as a teacher, when, you know, you're having people progress meetings or whatever, and people are perhaps saying to you, you know, this child should be here. Why are they not here at a particular level of attainment, for instance? And you think, well, because they're not. You know, they've got other things going on in their lives. And I know often it's just a case of discussing that perhaps and seeing how we can help them. I'm not against pupil progress meetings, but it can be a little bit frustrating to think that we just see children as statistical data, because they are very much not statistical data, are they?
And we don't necessarily make progress in a straight line either. You know, we don't do this. Nope. It's very much about peaks and troughs and all sorts of things. It's not that straightforward, is it?
No, my progress has definitely not been linear over the last few years in any way, shape or form. So it's unfair to expect children to follow a particular path, I think. I think that's probably enough about predictions. I can predict, Becky, that you are going to have a fantastic holiday when you eventually get there.
Yeah.
I hope you do.
Thank you very much.
I hope everybody else, if you are working in a school, I hope you're having a lovely summer break. If you have anything that you would like us to discuss or share our thoughts on in the Primary Maths Podcast, then you can email Becky.
You can email primarymathspodcast@twinkle.co.uk, no E on Twinkle, and we will get back to you. We'd love to have some emails.
I was just checking that you hadn't already checked out for your holiday there, Becky.
I
You're still there with us.
It's nearly gone.
Yeah.
It was
Yeah, or you can find us on any of the usual social platforms. Otherwise, we will be back in September with our standard offering, which is a interview episode on a Tuesday and a Aftermaths episode on a Friday. But we'll also be back next week with another summer special. So we look forward to seeing you then.
Thanks for joining us today. We'll see you next time.
Take care, everyone. Thanks so much. Goodbye.
Bye.
That was rude.